Okay, thanks. Thanks, Gianni, and thanks all the other organizers for giving me the opportunity to speak at a fun event. I think it's a fun event. Yeah, a little bit about me. I'm Patrick Barel. I've been doing Oracle since about Oracle 7 since it was 97. I started playing with SQL and then moved on to PL/SQL. That was about 99. And that's mostly what I've been doing ever since. For the last, man, it's been 20 years already. For the last 20 years, I've been doing SQL and PL/SQL. I've become an ace in 2011, and last year I was promoted to ace director. So yeah, and that's mainly because I talk a lot. I talk on different conferences, but I also created a couple of plugins for PL/SQL Developer, not SQL Developer, PL/SQL Developer, which is my tool of choice. I've also written some articles. I sometimes write something on my blog. I've written a couple of articles for All Things Oracle, but they died. The site went down, but I found that they moved my articles to the Simple Talk location. And I've also written a couple of articles for OTech magazine, but that also died. So I've created a couple of, I've moved all the articles to my own blog site. So if you want your publication to stop existing, ask me to write for it. Chances are it will die as soon as possible. These are my contact details. I'll send the PDF of the presentation to the organizers so they can give it to all of you. And well, as I said, I'm an Oracle ace. I've been that for almost 10 years now. And if you know somebody who wants to become an ace, or you think they should become an ace, nominate them using the acenomination.oracle.com. Please don't nominate yourself, because that's like, oh, I don't have any friends. I just want to be an ace. I want to be in the ace program. As you all know, probably all know, the Oracle offers the Oracle Cloud infrastructure in a free tier option. Go to oracle.com/cloud/free and get an always free cloud database for you to use for unlimited time. It will never expire. Well, maybe you have to log in every 30 or 60 days or whatever, but we're all professionals. We know how to build scripts for that. Okay, topic of today. Gentle introduction to polymorphic table functions. Picture this. It was 2017. A colleague of mine went to San Francisco. What's happening in San Francisco? Oracle Open World. Oracle Open World 2017. And he came back to me and said, hey, I heard something, but can you tell me in Tom and Jerry terms what polymorphic table functions are? Polymorphic table functions. It got me thinking, are you out of your mind? Only the ANSI documentation is a 200-page document itself. I started reading this, and after about 5 or 6 pages, I got completely lost. But it made me think, what are polymorphic table functions anyway? So what do you do when you're lost, you want to know something? I go sit behind my computer and I go to Google. Google knows everything. Well, they pretend to know everything. When I typed in polymorphic, I learned that it came from a Greek term. So what is polymorphism? Polymorphism comes from 2 Greek words, poly, meaning many, and morph, meaning form. polymorphic means many forms. But we've had that for forever. We've have a database, and in a database you have tables. And table is one object, but it has many forms, many different sets of columns, probably many different numbers of rows in the columns. And even a table can have many forms. If you build views on top of the table, you can display many different forms of the table. Back to the question, can you tell me in Tom and Jerry terms what polymorphic table functions are? Tom and Jerry. Well, I went and looked on the internet and found these images. And I also included Spike because I needed a third character. But what do these characters have in common? Well, they are animals. They have ears, they have eyes, they talk like humans, but essentially the animals, they speak. And I've looked up the speech in different languages. I found it in English. It says meow, squeak, and woof. Can I implement that in PL/SQL without the use of polymorphic table functions? Well, trying to implement this, I found out there are two different types of polymorphism. There's static polymorphism, where at compile time, the compiler decides which part of the code is going to be run. If you have the static polymorphism, you can do that in a package using overloaded procedures. I've created a package Tom and Jerry, and 3 different procedures in there, all named speak, but they differ in the names of the parameters: cat in, mouse in, and dog in. And they all have, this is the package body, they all have different implementation, which actually just says the name which you send in says, and then the word it speaks, says meow, says squeak, says woof. If you call this, you call the package Tom and Jerry speak, you tell it to use cat, the compiler decides it's going to use the first procedure in this package. Same thing for the mouse, it's going to be the second, and for the dog, it's going to take the third procedure in the package. If you run this piece of code, you get this output. Call the same procedure over and over with different parameter names in this case, and you get different output. The other form of polymorphism is dynamic polymorphism, and that's when not the compiler doesn't decide, but at runtime it gets decided which piece of code is going to be executed. And we can do that in PL/SQL using objects. We create the Tom and Jerry object with a name and a member procedure, speak, and then under the parent object, we create the different child types. Tom under Tom and Jerry, overriding the member procedure, and in there it says the name, which is a property of the parent object, and then it says meow. And we can create a different type for Jerry, it says squeak, and a different type for Spike, it says woof. And if we call this, we create a variable based on the parent type, the Tom and Jerry type. And if we add the Tom child type to the parent type, it becomes polymorphic, becomes the child type. So if you call the Tom and Jerry .speak, it knows I'm of type Tom, so I have to use the Tom procedure. And for Jerry and Spike, same thing. So if you run this, you get pretty much the same output. But then, of course, there's somebody else. There's another character, the little quack. If you have to do, rebuild, no, if you're using the overloading, you have to rebuild the package and the package body to add the extra character, the extra procedure in there. If you're using the types, you can just create a new type under the parent type using the exactly the same code as before, only this time we call it little quacker, and the quacker says quack. So if you run this, pretty much the same. It now knows at the last couple of lines, it knows how to use the little quacker, and it knows how to say quack. Another option for this is to use table functions, normal table functions, not polymorphic table functions. We create a table, Tom and Jerry, name and sound. We put in some data, then Tom, Jerry, and Spike. I started with without the little quacker, just to show you I don't have to change too much. We create a type based on the table, and we create a table type based on the type we just created. And then you can build a package Tom and Jerry, with a function speak, which returns the table type we just created in a pipeline fashion. And in the body, what we do is we select all the data from the table, and we return that as the Tom and Jerry types for every row. And if we call this, select name says sound, we get the output we expected. And then if we add the Tom and Jerry, the little quacker to the Tom and Jerry table, all we have to do is rerun the query, and we add this character to our set of sounds. So using table functions, you don't have to do anything. You don't have to rewrite any code or write any new code to show the to cater for the new records. But then somebody came along and says, well, it's all fun and good, but you're Dutch. Can you just let them speak Dutch, meow, piep, bluff, and quack? Well, we can do that. We just alter the table, rename the sound column to English, because that's actually what it is. And we add the Dutch column, and then we update all the rows to tell them what the Dutch version is. And if we call the same statement again, we get, of course, an error, because the package has errors. That's mainly because the type has been changed. The type should now cater for English and Dutch instead of sound. And if we change the query to select English, we still have errors in the package. We have to change the package to make sure it selects the name English and Dutch from Tom and Jerry. So the table has changed, so we have to change the pipeline table function to let it know what's going on in the table. But then we can call it, select the name in the English version, and we can select the name in the Dutch version, and it will show you the right output. And then somebody comes along, well, you got two languages now. You can probably do a third. Do it in Spanish. Meow, leak, cow, quack, quack. But that would mean going back into the code and changing all of the stuff again, again, and again. Remember, this was a procedure or a question that was asked at the end of 2017, just before the Oracle 18c database was available. I didn't have an Oracle database at my disposal just back then. The chances are you will not have the latest version on your laptop at this moment, which is probably 20C, or yeah, it's probably 20C. But there's always the Oracle Cloud. Oracle Cloud has the latest and greatest database available. And if you don't use the cloud, the always free tier cloud, you can still use Oracle Live SQL. Live SQL will show you, will give you pretty much the latest version of the Oracle database. I think they're now at 19, but maybe they've already changed to 20. In Oracle Live SQL, you can build your own scripts. You can learn from scripts somebody else has created. You get your own schema, and you can create just about everything: tables, views, procedures, packages, sequences, everything. Only thing is, if you log off, you log back on, everything is gone. It's not persisted. So make sure you save your scripts. Like I did, I've created the Polymorphic Table Function split column, which is saved in the Oracle Live SQL. Another nice thing about Live SQL is you can use Quick SQL. You just have to type the shorthand version, and it will create the right side, the output for you. But if you don't want to use Live SQL, you can always go to the free tier and use that one. Probably you'll have the same version available. But this was 2018. There was no Live SQL, no free tier back then. So I went to Live SQL. And what I did is I created a script. I saved the script so I can run it over and over again. Creating a table using the English and Dutch. Just start off with the two languages, put in the values. And then we have to create a pipeline table function package. The pipeline table function package has one mandatory function, which is the describe function. It always has a describe function. In the body, we can tell it what we're going to do. We're going to show for all the columns that are coming in, we'll tell it to show this column, and or on the other hand, we can hide the columns. And then we have to create a wrapper function, which is a standalone function, which calls the pipeline table function row polymorphic using the package. And if we then select from our package or our function Tom and Jerry speak using the table Tom and Jerry, and we tell it to show the columns name in English, it'll just show the columns name in English. If we execute almost the exact same query, except that for this time we ask for the columns name English and Dutch, we get that as an output. If we insert the little quacker to the into the table, we can still query, use the same queries, and we see the little quacker being displayed as well. If we alter the table and we add Spanish, and of course we also have to update the rows in the table to show the different speeches in Spanish, we can do the exact same queries, only this time we can also display the Spanish one. Nothing broke, nothing, no more code has been written. That's just kind of magic. We can even create a different table. In this case, I've created a table of numbers where the first column is now a number where it was a varchar before, and we can put the different values in there, and we can still call the Tom and Jerry speak, which is maybe not a very good function name for this, but it works. We put in the numbers table and we tell it to show us all the columns available. And we can still call the same function with the Tom and Jerry table, and it'll show us the data from the Tom and Jerry table. I'm keeping a short eye onto the questions list. No questions yet. So either it's all very clear or I've lost you all. Let's say you get a separated list. We get separated lists of these characters. There's something in this the chat. I'm not checking that. You get a separated list, maybe separated by semicolons, maybe by slashes, maybe by columns. Let's say you have a list separated by commas. Tom, Jerry, Spike, Little Quacker. And you want to split that list into different values. Like I said, you always have one function that is supposed to be there, the describe function. And then this time I also have a fetch rows because that's where the magic actually happens. In the package body, I create, the first column of the table sent in is going to be read for read is true, and then it doesn't get passed through, so you don't see it back in the result set. So pass through is false. And then after that, for all the columns sent in as a in the columns parameter, I create new columns which has a default table type, data type of varchar2 with a length of 4000. And instead of returning the original set, will return all the new columns. Then in the fetch rows, that's where the magic happens. First, I want to know which column I have to split. In this case, it's going to be the first column, so I get the name from the first column. And then when I get the row set, I'm gonna look for every row in the row set, for every row in the row set. Then for every column, no, excuse me. For every row in the row set, I'm splitting the first column into separate values using a regular expression, which I found on Alex's blog. I'll get to the question in a moment. And then after, at the end, we'll just send back all the new columns. And that's moving. And then, of course, we have to create a wrapper function. You can put the wrapper function inside the package, but I like to put it outside of the package function. And this is how I used to do it. I used to get a separate list, Tom, Jerry, Spike, Little Quacker, and I would have to write the regular expression over and over again. And if the list changed, if there's going to be one more or one less, I have to change the output of the select statement itself. Now all I have to do is select star from the separated function, put in the table, and show me the columns first, second, third, and fourth. I've got a question here. Can we avoid given columns list? Let me see. If in the question is, in the Tom and Jerry example, can we avoid given columns list or use star instead of naming Dutch, Spanish, etc.? Is there a way to default to all possible columns from exact same input query? Once this same SQL gives 3 columns, later it can give 5 or 6, but more languages are added as per this example. If you do select star, it'll show you all the columns that are going to be returned. If you do select name, comma, English, it'll just show you name in English. If you do select star, it'll show you name, English, Dutch, Spanish. And if you have Polish or French or whatever columns extra, it'll show you them as well if you do select star. I hope this answers your question. If not, please let me know in the question and answers. I'll close this one. What am I doing with that? Okay. So that was the separated list. Then, okay, now, yeah. Then I had this friend of mine, a different ex-colleague, come up to me and said, hey, you're always looking for use cases for polymorphic table functions. Since I think there's going to be only 5 or 6 use cases for the polymorphic table functions. And I probably built about 4. Why don't you build a sum interval function? And it got me thinking, well, that might be a nice use case for the table semantics polymorphic table function. What we just saw was a row semantics PTF. Everything we had to do could be done within the same row. We got a value and we split that up, and we didn't have to go forward or backwards to see what's been going on. In this case, we're doing a sum function, which is going to be table semantics. We have to know more than one row. Let's first try something out. We'll create an intervals table. Create a table with intervals year to month and interval date to second. Put some data in there. And just to make sure it's easy for me to add this up, I just used 1, 2, 3, and 4, which adds up to 10. And if we try to do a sum of either the year to month interval, we got an error. The Oracle expects a number, but got an interval. But if I do a select of all the different individual values, I can add them up. I can do an interval 1, 1 plus interval 2, 2, and it'll show me the correct value, 10 years, 10 months. Same goes for the date second interval. It expects a number, but you can do it yourself by adding them yourself, adding them up in a select statement. When I create a new package for this, a new polymorphic table function package, I'm again creating a describe function, and I'm again providing a fetch rows. So there's no difference there. In the package body, I have to create a type which is going to be used later on for the different sums that are going to be available. We cannot add year to month to and date to second, so we have to split that. And then also for every column that is going to be queried, we mark everything for pass through as false, so nothing's going to be shown. And the first we mark every column to be read, not to be read. So if there's a number or a varchar function column there, it will not be read unless it's one of the columns we're interested in. So if we then we run through the different columns that are in the columns parameter and mark it to be read. And for every column that's going to be read, we'll remember we're not going to pass it through. We're also adding a new column which has sum underscore and then the same name as the original column and then underscore at the end. And it has the exact same description, the exact same type. So if we're selecting the year to month interval, we get a sum year to month interval as well. Then we return that, and in the fetch rows, we get the environment, we get a variable to hold all the year to month intervals, and we also create a variable to here to hold all the date to second intervals. And then in the function, we get the entire column. And when the column is of the type interval year to month, we just add up every single value to sum them up by hand. We have to initialize it by with a 0 to 0, 0 year to month. Because if you add something to null, the result will be null. So we have to create a starting point. And then just run through all the rows in the column or the values in the column and add them up together. Same goes for the interval date to second. In this case, we start with 0, 0, 0, 0 date to second. And then for every value in the column, we add them up. And I've learned from Oracle, if something else happens, we'll say, well, columns of this type, if for instance, you do a sum of a varchar, are not supported. And Oracle now says it's not supported yet. So try to add that as well. And then we completely ignore the current row set and we'll just send back the different values, different columns. And the columns just have a single value, which is the sum for the interval year to month or interval date to second. And that should move automatically. And then we create a wrapper function for this polymorphic table function. but in this case, we say pipeline table polymorphic using the package, the PDF package. Whereas in the previous one, we said polymorphic pipeline row polymorphic. Now, again, try to get the sum for the interval year to month. We get the error, as we saw before. But if we run the PDF function, sum interval, on the table, and we're just interested in the year to month column, we get the sum interval year to month total. And doing the same for the day to second, we get the error when running a sum select. And if we use the sum interval function, so the polymorphic table function, we get the result we're expecting. If you want to read more on polymorphic table functions, I've written 2 blog articles on my blog, Polymorphic Table Functions and Table Functions Part 2. And if you're interested in how I built the polymorphic table function, check out the PDF split column. And then there was another version where I had a variable column name. The first version just had always split the first column in your table or your results that you sent in. The second one had I could split any column, and the third one I could split any column and have a variable separator. I don't have to use the comma or the semicolon for that. And while we're at it, you guys are watching webinars. We at Prodigy also organize a weekly webinar, Meet the Oracle Masters, the Online Shavers. We already did at the webinars by Connor McDonald and Maria Colgan, but there's a couple more where you can, which you can attend. Tomorrow, Stephen Forrestin, and a couple of more every Wednesday at 3 p.m. Central European Time. So that's leaves it open for questions and answers. Are there any questions at this point in time? I have no open questions.
So yes, apparently no questions. It's either thinking in process or it was just perfectly clear. One of the two.
I hope the latter, but
I mean, it made sense for me, which means a lot, not being a database person. So,
okay.
You have a question in the chat. Take it from there.
I'll have to.
Can you say it?
Okay. Let me see. Where can you polymorphic table function? Where can be used polymorphic table functions? What applications we have? I'm rephrasing that. Hopefully, where can we use polymorphic table functions? And is there a use case for this? Well, like I said, I think there's about 5, maybe 6 use cases for polymorphic table functions. It's really a rather niche part of the Oracle database. It is. Why did I check it out? Just because it's fun. It's fun to learn some new stuff. And I'm thinking I'll be using the separation function, like I said, in the like I displayed on the slides in my current assignment. Only thing is they have not moved to Oracle 19 yet, which is going to be done in a couple of months or so. So that's one I would like to use, because I'm now writing code over and over and over again for different layouts of the separator list. The sum interval is kind of a special thing. You can create your own functions on top of SQL. And I've also, what have I also created? I've created a polymorphic table function which creates a hash value for separate columns, which can be used. But yeah, I think there's going to be just a couple of crazy people like me building them and distributing them, and everybody's going to be using the polymorphic table functions. And I have another question here. Sorry, I meant, can we give SQL as select start from PDF tables columns star? Ooh, can we select start from PDF function and then the table and then column star instead of table columns and then the different names? I'm not sure. I'm not sure if you can send in columns with the asterisk. I don't think you can. On the other hand, you got control over everything, so you can probably catch somebody sending in star and then using all the columns there. I think you can send it in, but you have to build your own code to be able to work with that. I hope that answers the question. Yes, okay, thanks. Yes, it does. Nice, thanks. Any other questions?
So, if you can still stay online for a few minutes in case something else will come. In the meantime, thank you very much, Patrick, for the presentation. It was really interesting. And also from my side, a reminder, check out the QuellLogic Meet the Masters series online sessions. It's free to attend, great names, so give it a look.